Thank you very much for the introduction. My name is Dan Norris, and I am here to talk about running Cilium with Nomad. As mentioned, I'm the infrastructure lead over at a company called Cosmonic. And there we go. So I'll briefly just go through kind of what we're going to talk about in this talk. So I'm going to first start off talking about what a CNI is, why do you want to use that with Nomad, and then I'll give you a brief overview and intro into Cilium and why we chose it for our use case. Then I'll talk about some of the challenges that we've encountered while running Cilium and Nomad paired together. I'll introduce a project that we are working on open sourcing. It's not open source yet, but didn't make it by the deadline, called Netreap as a solution to some of those problems. I'll give you a brief demo as to what we have set up and what it looks like, and then highlight some of the future work that we have. So I'll just jump right into it. So if you've been in the container space for a while, you've probably seen the acronym CNI. And what that stands for is Container Network Interface. You typically see these more often used more in the Kubernetes world, right? Because they have a lot more strict network requirements than Nomad, 1 AP per container, all that sort of stuff. Generally, you tend to use a CNI to sort of provide those capabilities. And so it is just a spec and a set of basic libraries that implement base networking things like bridge networking, host networking, stuff like that. Many companies actually are in the business of producing their own CNIs for various purposes. This has actually been supported in Nomad since 0.12, so it's been a while. Though typically, I'm not actually sure how many people tend to run with a CNI in production. But what it allows for is to, at least from a Nomad perspective, is to have a lot more control over how your tasks are networked together. Decide how they are able to reach the public internet, how they relate to, and are able to network to each other. And so a lot of the motivating reason as to why we use a CNI, and in this case Cilium, is that we wrote our own Firecracker task driver for Nomad. We happen to run at Cosmonic a platform as a service for WebAssembly applications. And so at some point, we cared deeply about network security. And so Cilium was our answer to being able to provide that as a platform. So you can check out this talk. We actually gave it at HashiCorp last year, Distributed Flexibility, Nomad, and Vault in a Post-Kubernetes World. So if you're curious as to how that all sort of fits together, I'd check that out on YouTube. And so Cilium itself is just a CNI plugin. There's a corporate entity behind it, Isovalent, but it's also a CNCF project. And what's interesting about it is it's actually a plugin that's implemented using a technology called eBPF that basically controls how all the data is synced up. eBPF is a technology that's in the kernel. Basically, it's like a virtual machine that runs a bunch of code that you can write in pretty much any language and targets this machine. I'm not going to go into too much depth in this talk just because this isn't an eBPF talk. And honestly, it's a complex enough topic. It could and should be a talk to itself. But what's interesting from our perspective as people who are operating Nomad is you can actually run effectively a hook or a command or really a code down to or as granular as every packet that's processed by a machine. And so that's effectively what Cilium does. It's able to process pretty much everything at that level. And it's super fast, super performant. So it works for us and for our use case. And the other big reason that we chose it is there's a component to Cilium called Hubble, which I'm not going to talk too much about actually in this talk. But it's effectively like a big tap into your networking. So you can inspect all egress and ingress traffic that comes out of it and generate metrics from it. To be able to do that in anything that's not open source would be ridiculously expensive. So the fact that it just kind of comes out of the box with that is pretty impressive. Some other features that we use out of Cilium that, again, are core to our use case and our decision to use it is the fact that it ships with a concept called network policies. Again, this is very much something that comes out of the Kubernetes world where you want to be able to apply a policy for a particular workload, right, that dictates what it can and cannot communicate with. It's effectively like a programmable firewall for containers. And so what it allows you to do is you can do things similar to what you might be able to find in something like a Console Connect, where you can restrict traffic between from one service to another, or only allow one service to communicate with service A, but not service C, or something like that. Pretty easy to define in Cilium. But you can also dip lower level, right? You can restrict policies to particular CIDR IP ranges, particular DNS entries. So it's pretty powerful, right? It depends on what your use case looks like. The other big thing for us also is that it provides transparent encryption in transit, and it does that either using WireGuard or IPsec. We use WireGuard, which is pretty performant and pretty easy. It's just built right into the project itself. And you don't need to worry about TLS in that case, right? So we're not using a service mesh, right? We considered it with Console Connect, but it didn't quite meet our requirements. But it does give us encryption without having to worry about TLS, which is pretty convenient. But some of the challenges of running Cilium kind of are a little bit structural with Cilium as a project. It effectively only works with Kubernetes, right? It is, and I think that's a deliberate design decision on part of the project, which I think is reasonable given what they're trying to target. But a lot of the bookkeeping that Cilium does behind the scenes is actually driven by a Kubernetes operator called the Cilium operator. And what that does is it spends a lot of time basically making sure that IP addresses are allocated and deallocated properly, that individual endpoints or services are labeled correctly, and those labels are updated, and also distributing network policies to all the various things that are running Cilium agents. So we had to do something for that, and we'll talk more about that a little later. And if you're not going to use Kubernetes, right, it means you have to interact with Cilium at a very low level with some very, they're not quite internal APIs, but they're not as easy to use as, say, some of the stuff that you get on the Kubernetes side. So that was a bit of a challenge, and I'll describe how we worked through that in a little while. The other thing is, and this is like kind of a Nomad quirk that we learned, is that when you start a Nomad server, it goes through, or really a Nomad agent, I should say, or something that's running a workload. It goes through a process where it scans the system and figures out what capabilities that agent is able to provide. So if, for example, you have Docker installed, it will fingerprint, which is what this is called, and say that, yes, I have Docker available. I can run Docker containers or any jobs that are Docker. And with CNI, it's the same thing, right? It has to be, when the agent starts, it profiles and finds that a CNI is available. What that means for us as operators of Nomad is that you have to make sure that Cilium is running before Nomad starts. And so I'm going to spend a bit of time talking about how we solve that. And spoiler alert, it's systemd. But we'll go into some more detail in a bit. So there are different approaches to this, right? So if you're going to run Cilium everywhere, right, it needs to run on every host where you want to be able to provide that as a CNI. Normally, this is what you would use Nomad for, right, or any other orchestrator. So there are different approaches to take here, right? You can do config management, you can run containers, you can do whatever. I'm going to describe what we do, but if you were to try and replicate this on your own, there are many other approaches. But we run them as Docker containers scheduled through systemd, so that's what I'm going to describe. So with Docker, there are a couple things that you need to make sure are taken care of. The first, and I'll go into depth on each of these points. But the first is to make sure that when you start Docker, the default bridge network has a different CIDR than whatever you're using for Cilium. They can conflict if you're not careful. So my advice is just to set it statically, and I'll show you how to do that. Second, you need to make sure that the CNI plugin for Cilium is configured and that all the base CNI plugins are actually installed in the host system. And thirdly, you need to ensure that the Docker container, which is how we're running it, is actually running on every node, and it needs to be configured to talk to console. So first step, as I mentioned, make sure that the Docker bridge is different. The way you do that is on your host where you want to run Cilium, you go into etc docker daemon.json, and you actually set an explicit address pool. In this case, in this example, I'm just using 192.168.0.0/24. That's basically the IP address range that a lot of routers ship with. It gives you about 220 or 255, I should say, usable IP addresses, which is fine as long as you're not planning on running more than 255 containers at a given time that are not Cilium enabled. So that's something to like keep in mind. You can change this to whatever you need to in production, and it doesn't make a difference as long as this doesn't conflict with Cilium. Next step to make sure of is that you have all of the base CNI plugins installed. Some distros have them in the repositories. Usually it's just easier to install them directly from the GitHub repo. So I provided a link in the slides, but you can go to the container networking repo and check them out. But you also have to have a configuration file for Cilium so that Nomad knows how to start the plugin when you invoke it. This is similar to what the Nomad docs provide. In this case, it's a much more stripped down version though, because you don't have to like chain anything. So here's an example. So if you have a Nomad system and you want to enable Cilium on it, you would go into opt CNI config and create a configuration list. So in this case, I have a file called cilium.conf list. The name is Cilium. I declare the CNI version outright, so 1.0. There are different versions you can lock to, but 1.0 is fine. And then you just declare the list of plugins that you want it to chain together. Cilium's kind of all-encompassing, so you really only need to run it. So you declare that its type is a Cilium CNI, and then you can enable debugging if you're trying to do low-level stuff, or you could not. In this case, I don't, since it's not something we strictly need. And lastly, we need to make sure we actually run Cilium everywhere. So again, I mentioned that we happen to use systemd, and we actually run Cilium as a Docker container and just as a systemd service. If you wanted to, you could use Docker Compose on that system. You could do, run a Docker container and run it as a daemon, and it would restart when the system restarts. But the important part is that Cilium must run before Nomad runs. Like, I can't emphasize that part enough. Your tasks will not run if you're running a CNI if that is not up, because the agent will not know that the CNI is there, and you will not be able to run anything. And it also needs to use Consul. Cilium, the project itself, ships with support for etcd and Consul. More than likely, if you're running Nomad in particular, like you're already running with Consul, so that's easy. But if you're not, you would need to have a Consul cluster set up. The other thing about Cilium is you definitely want to use it running Docker. Like, you could install, it's just a Go binary. Like, you could install it by yourself. There's a couple tools that come with it. But the way that Cilium works, since it is running everything as ePPF, it actually compiles them. So you need to have a version of Clang installed, which means you would have to install Clang on every node. Start seeing how this is sort of seeming difficult. But it also uses their own internal fork of IP Route 2 and libbpf. Both of those are open source, but they would have to be also present on the host system. So I tried going down this road actually and like hand installing everything and decided it just wasn't worth it. So my recommendation is just run in Docker, just run it as systemd or a Docker Compose job, whatever, right? You will be much, much, much happier. You don't have to maintain any of the dependencies. And lastly, you just have to make sure IP tables is enabled and all the modules are loaded. Cilium does do some low-level IP tables stuff, so you just need to make sure that they're enabled in the kernel and ready to go. So as an example, here is what I've thrown together for a systemd unit that actually runs all this stuff. And really, all this is doing is just making sure that the container is started after or before Nomad, but needs Consul, needs networking, needs Docker. Mount in a couple of different directories from the host system, namely a socket that communicates with the Cilium API. That way you can expose that to other things, which you're going to need in a little bit. And then also mounts in the BPF facility from the Linux kernel. It also, because it's doing a bunch of low-level networking stuff, needs plenty of capabilities to do so. So netadmin, netraw, a few other capabilities. And And then further down at the Cilium agent line, that's where we actually configure the running Cilium process. So in here, this is where you declare things like you're enabling or disabling things like IPv6 or encryption. In this case, we declare an IP range, we enable WireGuard, etc. So this is just an example. You would end up tuning this in your own environment. So as I had mentioned, one of the things we found out when we were going through this process is that everything's very Kubernetes dependent, at least if you're trying to do bookkeeping and make sure everything's sort of staying up to date. So we ended up writing a little Go binary that can run within a Nomad cluster called Netreap to kind of help take care of that stuff for us. We originally chose the name just because all it was actually doing was cleaning up old IP allocations. And then we realized we needed to also sync policies as well. But we kept the name because it's honestly a pretty good name. You can think of a nice logo and everything for it. But again, like its main responsibilities and what it's doing for us is cleaning up all the old IP allocations whenever a node comes up or down. And then also syncing all the network policies across all of our Nomad hosts where we have Cilium installed. So a little bit of kind of like an architectural digression, but a single Cilium cluster manages one subnet across all nodes in the cluster. So in the service that I showed you before, I actually allocate a 172.20/16 address range that gives you like 65,535 usable IPs, which is a pretty good amount of IPs. Like more than likely you would never blow through that. However, now that we live in a containerized world and containers can spin up and down kind of whenever they need to, you can, in theory, exhaust that, right? So we needed a solution to make sure that we didn't end up allocating all the IP addresses in that space, and we wouldn't be able to run any actual containers ever again. So Netreap fills in for that role for us. One of the things it does, it monitors for Nomad agents as they come up and down. It goes through and periodically cleans up old IP allocations as jobs spin up and down. And the reason it's monitoring new Nomad nodes in particular is that it is also removing stale agent entries from the cluster. One of the things that Cilium does is it health checks the whole cluster, right? It tries to build a topography of everything that happens to be running at the time. So it runs active health checking against all of them. And if you don't periodically remove old nodes, your health checks will start to fail because it just takes too long to kind of get responses back, or it just looks like the cluster is unhealthy when really it's fine. So that's one of the things it does for us. And we actually ended up building in leader elections so that only one running Netreap process at any given time is responsible for handling that. That was another thing that the Kubernetes operator was just able to do out of the box, just because you have those capabilities just in anything that happens to be running in a Kubernetes cluster. The next thing that we end up using from Netreap was the Cilium policies, or the network policies. And in Kubernetes, they typically follow the established pattern of having a bunch of CRDs, or custom resource definitions, for managing network policies. They have little snippets that you can kind of apply, right? You can say that for one workload, this is the network policy. For another workload, it's that particular network policy. And the Cilium operator would actually merge all that together, because when it gets down to being applied in an individual node, it's one big JSON file. So normally that operator is what does that, but we needed a solution to be able to sync all those policies and make sure they're all one coherent thing. So what we do instead is this JSON policy file, which we just manage one of, is just stored as a value in console as just a key value bucket value. So it pulls that periodically for changes, and anytime that is updated, it gets applied automatically. And I'll show you what this looks like in a little bit. So that's sort of the high-level overview. I wanted to show you a quick demo of what this looks like running on an actual server. So I'm going to flip over to my terminal real quick, and we'll go through, and I'll give you just a brief overview of some of the some of the job specs look like in this running Nomad cluster. It's really just one node. And then I'll run through, and I'm going to go through an exercise where I'm going to have a policy applied that allows all egress traffic from the container. I'm going to apply a different policy that actually blocks traffic. And so we'll be able to see that networking is effectively, or I should say egress networking is effectively disabled at that point. And then I will flip it back to the old policy so you can see that update in real time. And I'll also show you what some of the endpoint labeling looks like. So what I have up on my screen right now, which hopefully everyone's able to read and the text is big enough, is a job spec for what Netreap looks like. And right now it doesn't take a whole lot of options. It's fairly straightforward Nomad job spec, but what we do is we give it the CIDR range that it needs to be managing. So in this case, it's that 172.20/16. And then before I had mentioned that we were exposing the Cilium socket from the running Nomad or Cilium agent that we had started with our systemd job. The reason we do that is so that we can actually also bind mount it into this running container so that Netreap is able to communicate with the Cilium API. So the workload we're going to run is just kind of a take on the Redis container example that you can run through Nomad init. So this is just a job that we call example. And because we can do endpoint-based restricting or allow listing right in Cilium, Netreap allows you to apply labels to individual endpoints just by pulling out of the Nomad metadata. So in this case, I have just a key called cosmonic.io/conference. The value is Hashi Talks because we're giving this talk Hashi Talks. And so what we do in here to make this a Cilium-enabled container is we set the mode in the network block to the CNI of Cilium. We declare just a static port that we can advertise in Consul as a service. We declare the service, just call it cache, reference the port, just give it some tags so they're visible. And for Docker in particular, this is important. We set the address mode to the alloc. So that way, certainly, and especially when you're kind of pulling things around in Nomad, it actually pulls the correct IP address as opposed to trying to get your host IP address. And everything else is the same, right? We're just running a Redis container, right? And just give it a few resources. That's straight out of like the init example that you can get by running Nomad directly. And so the policy that we're going to apply, I'm not going to spend too much time going into the specifics of this, right? It's a lot of syntax. But the policy at a high level, what this is doing is each of these entries are an individual policy, and the whole list in JSON is all of the policies that get applied to the node. So in this case, we have two policies. We have one that allows the Cilium health checks to go through specifically from remote nodes and from on the host. That's the first block. And the second block is what's allowing ingress and egress traffic to and from the container. So we're pretty not restrictive here at all, right? We're basically saying that allow all ingress traffic except maybe for multicast, just as an example of what that looks like, specifically from the host or remote nodes, so anything inbound, outbound. And then for egress, we're specifically allowing traffic from port 53 on the host, so that way you get DNS, and when I turn this off, you'll still have DNS. But we are explicitly saying that we're allowing all egress traffic except to anything on a 10./8, so anything basically private IPs or anything multicast, right? Mostly an example, but it will show you how to turn this on and off. The blocked policy, which we're going to apply, is the same thing, only minus anything about the egress block with all of the CIDR addresses that I just showed you. The reason is that Cilium, like many other types of software, goes to default deny. So if you don't explicitly allow something, or in this case, an egress policy that allows traffic to the public internet, you're not going to have anything. So with that being said, I'm going to go switch to this other tab where I am running Netreap just in a Nomad server here. So I'm going to, just an example, and we're not going to do anything with Redis. I was just using that as a place to get all this sort of stored, is I'm going to exec into the running Redis container that I had that was running that manifest I just showed you. I am going to ping google.com, which is doing its thing, right? We're getting traffic here. What I'm going to do now is actually apply through console the egress policy that blocks traffic. So just did that. If I go back to this tab where I was running ping, you see that it's stalled out, right? It's not doing anything. If I go ahead and try and reping, not going to work. Apps update. That's it here, install. The reason is because I denied it access to the network pretty much entirely by applying that policy. And if I undo it, go back to this tab, I'm able to ping it again, right? So that's Netreap in the background, watching that console KV value and applying and reapplying as needed. And the last thing I want to show you is I can get a list of the Cilium, oops, I want to get the endpoints. These are all of the endpoints that are running on the host system. So these are all the jobs basically in the IPs that have been allocated and their labels. So you can see at this bottom one, this is actually our running Nomad job. Netreap applies the job IDs, in this case example, just kind of by default. And we'll also apply any metadata. We use kind of a grouping key called Nomad. Here's the cosmonic.io/conference HashiTalks value that we had applied before. And here's that its IP address listed. So that's basically Netreap in a nutshell and what Cilium looks like when it's running. We have a few things that we want to do right in the future, right? The most obvious one for probably everybody listening to this talk is we want to open source it. Just didn't happen by the deadline, but that should happen in a couple of weeks. There's just some things we want to clean up and make it more generic and a little easier to run for people who are not Cosmonic employees, basically. So stay tuned to our Cosmonic Twitter account for that announcement. There may be other venues. Feel free to also reach out to me and I can let you know what our progress is on that. But another thing that we're looking to do in the short term, this would all be open source work, would be able to apply filters for Netreap so that it only tries to do anything for jobs where you flag it on and off, or by metadata label, or by namespace. So we should be getting to that in fairly short order. And with that, thank you for listening to the talk. That was pretty much everything I wanted to run through. So thank you very much, and I will hand it back to the organizers. Thanks for listening.